Okay, we're going to move on to the next part of your statistics project report, and that's including histograms into your report. And so we're going to first define what a histogram is in the definitions section, and then we're going to write about the histograms that I've created or that you'll create, and put that in the results section of your report. So as you can see right now, this is a copy of the report that I've made so far in Google Docs. And so we're starting here at the top of the first page. So on the left-hand side, we have the outline. And, I can click on these different parts to quickly get to different parts of the report. So the first thing I want to do is create a definition of what a histogram is. So earlier, I created a definition for the word inversion relating to the roller coaster theme of my report. Yours will look a little different. So kind of going in sequential order, I'm going to talk about histograms next. After inversion. And so you'll notice, for keeping things organized in the outline, you'll notice that the outline here is in different levels, okay, indented levels. So definitions is in the top level, or level 1, because I used heading style number 1 to define it. And you can see it says heading 1 up here. If I click on inversion, and you can see the word inversion is inset, so this is a level 2 outline. If I click on it, you'll see here I've defined it as heading 2. And the text below a heading just says normal text, okay? So when I talk about histograms, I'm going to title it with a heading style 2, and then normal text underneath it. All right, so the first thing I want to do is define what a histogram is. So I'm just going to hit carriage return a couple of times to create some space. And this is going to be distribution shape. And this is basically what a histogram is, distribution shape. And as I continue, realize this is all my work. This is all my wording. So, some of this stuff is from your notes, but some of this, is kind of my own way of writing this and expressing this. So, you can use what I'm doing as inspiration, but, of course, no plagiarism. You need to come up with your own way of saying things different from my own. All right, so let me hit carriage return. And so this is going to be, a heading style 2. And you'll notice this word distribution shape histogram is not listed here yet in the outline. But as soon as I select all of this, and I change the style from normal to heading 2, and I put apply heading 2. All right, it becomes boldened, and now it says distribution shape underneath inversion. It wasn't there before, and it is inset 1 level, just like inversion is. Okay, and down below, you want to make sure it says normal text, and this is where we'll start adding to this section. So what I came up with in explaining what a histogram is I said a histogram is a graph which represents a range of density of datums in a data set where bar charts are used to graph qualitative data, such as categories, histograms represent the shape of quantitative data. Histograms can be designed using the following 5-step process. Okay, so I try to summarize in just a few sentences kind of what the point of a histogram is and kind of relate it to something that's similar to it, but then giving an explanation of how it's a little bit different. All right. And then thinking about, what we've learned about histograms in class. There was a 5-step process for designing your own histogram. So now that 5-step process will make a really good thing to put in defining a histogram and how it's going to be used in this report. So what I'm going to do now is I'm going to add the different steps. So we're going to have step 1, which was to determine the range. And I'll just go ahead and type out all the steps. So step 2 was to determine the number of classes, okay, and the width, lowercase w, of each class. Step 3 is to find starting point for the first class. Let's see here. Step 4 is to create a frequency distribution table. And let's change, I'll leave that capitalized. Okay. And then step 5 is to create and format the histogram graph. All right. Now each of these, I would like them to show up here in my outline. So to get it to be inset or one level lower than distribution shape, this was heading style 2. I'll choose heading style 3, and that'll put it one level lower. So if I click here and I put heading level 3 and I put apply heading level 3, there, now it says step 1. And I can do the same with this one. Select it and choose heading level 3, apply heading 3, and do that with each of these. Apply 3. Apply, oops, didn't do it. Apply heading 3 and apply heading 3. All right, so over here on the outline, you can see underneath distribution shape, we've got another level that's inset, and we have our 5 steps. So now we just have to kind of explain very succinctly each of these steps. So we could say the range is equal to the difference between the maximum datum minus the minimum datum. And that's calculated with the range is equal to max minus minimum. And we wanted to we could, let me see here, should be able to center justify. Okay, so we can kind of move this formula into the middle. You don't have to. But, over here on the far right-hand side, you've got these three vertical dots, which says more. If you left click that, this drop-down ribbon item says align and indent. You can left click on the caret there and change that to center align or center justified. And it should move that there into the middle. And that's all I need to say about the range. So let's move on to step 2. So step 2 is, I hate it when it automatically does things for me. Okay, I just want a star. Let's see here, 2 formulas are used to calculate 2 class numbers, K1 and K2. One of the formulas is called the OpenStax formula. And we hit tab a couple times. And then the other one is called Sturge's formula. And the OpenStax formula. And let's see here. So we're going to be entering in some equations. So this might be a good time to introduce like an equation editor that Google Docs has. So if you click View, we want to turn on Show Non-Printing Characters. I should have done that at the beginning. So now we see carriage returns and tabs in there. But let's also view the Show Equation toolbar. And when you left click that, you'll see now you've got this toolbar right here. And so for the OpenStax formula, that's going to be K1 is equal to, and now we need to add square root of n. So you'll kind of see here where it says math operations. If we left click that, oh wait, I think we need to, we need to hit new equation. And then now you can see it kind of put a little box here. Now we can put math operations and put square root of x here. So this will put the square root sign, and then we want the letter n. And if we hit the right arrow key, that'll let us exit that little equation box there. And I will hit tab a couple of times. And K2 is Sturge's formula, and I don't think we need anything special to actually type this in. Actually just kind of type formula in like that. Nothing special is needed there. Okay, but we want to add, let's see here, where n is equal to the sample size, which is equal to the number of items in the data set. Okay, and let's see, I think after we have the like a range of classes, number of classes, K1, that's going to be one number. And then another number of classes is K2. We don't want that. Okay, next, after that, we need to calculate the widths, W1 and W2 of each class, K1 and K2, respectively. And so we'll have K1, W1 needs to be greater than the range. Tab a couple times. and then K2, W2 is greater than the range. All right, so this information, I'm getting from your lecture notes. Okay, so I'm not really making any of this part up. I talked about plagiarism, but in this case, all you're really doing is putting down formulas and explaining what the parts of those formulas are. So, you don't necessarily need to cite me, or my lecture on this part. This part you could, copy, but this part up above, you'd want to come up with that on your own. Okay, so let's see. So we could probably maybe go one more line lower and just say, width 1 will be greater than the range divided by K1. And the second width will be greater than the range divided by K2. And we will want to make sure that we round up. I hate it when it automatically tries to do what I don't want it to do. Round up W1 and W2. Okay. All right, so that's step 2. So step 2 is to determine the number of classes and the width of each class. So I explained which formulas are going to be used to determine the 2 number of classes to try. And each number of classes will have a width for each class to go along with it. All right, step 3 is to find the starting point for the first class. And so for this one, I just said starting point of the first class and be any number lower than or equal to the minimum datum in the data set. Using the minimum datum in the data set is the starting point which is used in this report. The starting point is equal to the minimum datum. All right, that's step 3. Step 4 is creating a frequency distribution table. So the frequency distribution table creates the structure which defines the histogram. So, for example, all right, now this is where we're going to, insert a table. So let's see, we do insert table, and let's see, I need it to be 5 columns wide and 5 columns deep. So 5 by 5. 2, 3, 4, 5. Yeah, that should do it. Okay. And so the column headings are going to be class number, class lower bound. I'm going to put an abbreviation there so I can use the abbreviation later. Class upper bound, so cub, and then class midpoint, and that is the class lower bound, plus the class upper bound divided by 2. So that was the reason why I put these abbreviations here, so that I could use them here to define the midpoint, how the midpoint is calculated. And then the last column is the frequency column. And so class number, we'll get like class number 1, 1, 2, and 3. And then dot, 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 meaning it continues downwards. Let's put n there, and we'll put a dot, dot, dot here. Yeah, that's good. No, actually not n. Okay, the number of classes. So, if earlier we calculated K1 to be equal to 8, then this would go 1, 2, 3, 4, 5, 6, 7, and the last one would be 8. Yeah, so let's do that. The class lower bound starts with the starting point, and the class upper bound for the first class will be the starting point plus the width. And the class lower bound for the second class will be the starting point plus the width. And everything else will just be adding like a cumulative width to each one. So W, no, go to the right. W, and then we'll just put dot, 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 to mean it just keeps going that way. Midpoint, we can't really fit anything in there. And what is it? Dot, 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 like that. Okay, so now let's see, it would be nice maybe if those were center justified. So I just selected all of them, and I'm going to center justify. And it would be nice to have these column headings in bold. So I'm going to select them all and put them in bold. And center justify that too. So let's center justify that too. All right. And we don't need that extra line, so take that out. Okay. And just really quickly, we'll say the class midpoint can be used to label each class in the histogram graph. And the frequency is a count of the number of datums in the data set found between the class lower bound and class upper bound class. All right. So I think that pretty much wraps up what step 4 is all about, creating that table. And step 5 is to create and format the histogram graph. So a graphing calculator or computer software like Microsoft Excel or Google Sheets can be used to create histograms. The default settings used by the calculator or computer software are often undesirable. Maybe instead of undesirable, let's say the default settings used by the calculator or computer software often do not reflect the specific data set reanalyzed. The default settings used by the calculator or computer software often do not reflect the specific data set to be analyzed. Okay. Therefore, histograms need to be designed and customized by the researcher. Below is an example of a properly designed and formatted histogram. Below is, okay, so let's put that. Okay, so we've been talking about histograms being a graph. It would be nice to put an example of what one looks like. So we're going to have a picture and a caption. So we want to insert a table that has one column but two rows, so 1 by 2. And so here in this top cell, I'm going to insert a picture that I have created ahead of time. Put those. Okay. Let's see, what's a good one? I'll just go ahead and sure, use this one. So I am looking at my file system and I'm just dragging over a picture and dragging it into that cell. It is too large. So let's see, I think I want to go to image options and under size and rotation, let's change the width. Now make sure log aspect ratio is selected so that if I change the width to 3 inches, it'll change the height and keep the relative size of everything. All right, that looks pretty good. I should be able to center that. Let's see, right here, align. So I can center it and that'll put it in the middle of the page. And down here, I need a caption. So I'm just going to label this maybe figure C. Example, histogram of speed per hour versus frequency. Each class is labeled by the corresponding midpoint, and the height of each class is defined by the effective frequency. There are 8 classes, so K equals 8, each with a width of, let's see, what was that? Each with a width of 9. So W equals 10. Starting point is at 4.5. Starting point equals 4.5. Okay, and that's actually a little bit of a lengthy caption, but it does kind of explain what we're looking at here a little bit better. Okay, so that is the definition of a histogram, or the shape of a distribution. So hopefully seeing me kind of think through this and type this out and going through the process of inserting pictures and captions, adding different outline levels, adding tables and formatting them will help you in learning how to do this for your own report. So that's going to be the end of this video. The next video will be putting in your data into the results section.